Now, one last thing I need to talk about. There are actually three different types of margin of error. There's what's called conservative, that's 1 over square root of n. Remember seeing that? This first showed up back in chapter 3 or 4, somewhere in that neighborhood. It's also the margin of error that's used for political polls, newspaper surveys, stuff like that. This is a 95% confidence or 95% margin of error. How do I get 1 over square root of n for a 95% margin of error? Does anybody really want to know? If you're interested. Set p hat to 1/2 and the multiplier to 2.0 and plug it in that thing over there, and you'll get 1 over the square root of n. That's all it is. It turns out that the confidence intervals are widest at proportions of 1/2. That's because you have a limit between 0 and 1. At the center is where they're going to be the widest. As they get closer to either side, they have to get smaller to keep from going over the end. And so the biggest confidence interval will always occur at the center, at 1/2. So if you take that conservative or largest interval, you're going to set p hat to 1/2, use your multiplier of 2 for your 95%, and you'll come up with 1 over square root of n. There's also a approximate, and that's going to be equal to 2 times standard error. That's the one that we've been using. And then there's an exact, which is 1.96 times the standard error. Okay. And if you're not told anything different, you can take your choice, usually between these two. Unless you know that p is somewhere near 1/2, you probably shouldn't use this one. But either of these is okay. If you will see me doing confidence intervals, I will almost certainly be doing this one because I can multiply by 2 in my head. I can't really multiply very easily by 1.96 in my head. So in general, I'm just going to use 2. Okay. You can do the same thing. If I don't tell you what kind of an interval, it's your choice. You can use 1.96 or 2. If I ask you for an exact interval, then I expect a 1.96 in there. Okay? Got about 20 minutes. This worked out pretty good at 1 o'clock, so we'll see how it does here. 8.53, 9.36, 10.24. So work on those. We'll start looking in about 5-10 minutes. We'll start looking at 8.53, probably closer to 10 minutes. Whenever you're working with these probability problems, it's always a good idea to draw the picture. I found that for a long time it helped me a lot, and actually sometimes even now it helps me. But just draw the picture and figure out exactly what it is I'm looking for. That way you kind of keep everything straight. But don't draw it in your eyes. picture for 1.4 will look a lot like this. And the picture for the area between those two, kind of look like a combination of both. And what you're going to do is, it's going to look like the area in between. So you find this area, you draw this one out. In about a minute, but I'll do it. Try to draw a picture. Question and answer, okay?
I'm still really I don't like, cause he kind of look at it, like, cause there's only one bigger, right?
Yep.
So, maybe we use this one. So there's two uses, agreed?
Yeah, no, this is one digit. 1.4. 1.41. I would add this to it.
You're funny. I'm not sure where you started me at all. I'm not sure where you got me too.
So the second
I
part
read the
of
question, it
the
just
same
like
as
two.
the
And I thought it was
And the third part is kind of a combination of those two.
maybe I don't know where I got one too. Right.
I wasn't sure about what you were saying, so I tried doing something else, and I doubt it worked out, but I just wanted to make sure. I tried, since this says below 1.4 and this is below negative 1.4.
Yep.
I got rid of the equal to or less than negative 1.4, which is 0.0808. Subtracted that from less than or equal to 1.4, and
That's exactly correct.
awesome, I still landed the correct answer. That's
As I said, I didn't believe that you didn't understand what you were doing. You're not comfortable with it yet.
I.
But you took, the logic you just told me is exactly the correct logic.
Okay.
Okay? And it is that simple.
Let me draw it up here. Okay, let's take a look at 853. So this one, the first one. So draw the picture. -1, -2, -3. It wants the area to the left of -1.4. So that is this area right there. If I look up -1.4 in table 8.1 at the back of the book, -1.4 is the same as -1.40. So that's the first column. And I end up with 0.0808 is that area. Okay? This one right here, what I want is 1.4 right here. So I actually want this area. That's the positive side of it. If I look up 1.4, what was this area right here? I think it was 0.9192. Okay? This one right here, there's -1.4, there's +1.4. What I want is I want that area right there. Well, that is this area minus this piece over here on the left. So this is nothing more than 0.9192 minus 0.0808.